The one-year mission currently going on the International Space Station right now with Scott Kelly and Mikhail Kornienko is coming to a close in just about a week. But that doesn't mean that the one-year mission is over. There's plenty of work to do here on the ground to continue to monitor these experiments. And with us today, we have Dr. John Charles, the Chief Scientist of the Human Research Program, here to talk more about the one-year mission. Dr. Charles, thanks for being with us today. So let's talk a little bit about what we were expecting from this experiment, from a one-year mission. Is there anything that has been going on that you know that you were expecting something to happen, and it actually did?
I was expecting great success, and we've had great success. The one-year mission has gone surprisingly well in terms of the investigations that we've been doing on board. The a couple of major joint investigations, which are really demonstrating how we can do much more collaborative work in the future, have been surprisingly successful. The astronauts have been very prompt and punctual in getting their work done, following instructions and their training very well. And we're anxious to get the astronauts and their samples back next week. As you mentioned, next week the astronauts land. Many of the blood samples don't come back until the next SpaceX landing, which is in April, so we're not really going to be able to start analyzing some of the data that they've acquired until April. But like you say, the work continues even after the mission seems to end. There's months and months of post-flight data collection. In some cases, up to 9 months after landing, we're still acquiring samples in the astronauts, perhaps even longer as they return to their normal duties and we acquire data from their annual physicals and so forth. And then the data analysis really begins. So we're looking forward to seeing the results of this first major collaborative work between the U.S. and the Russians on the ISS, with one U.S. and one Russian astronaut involved. Over the course of the next several months, see the story start to come together, see the results become crystallized, and then look forward to the publication of the results, we hope, starting about a year from now or so.
Excellent. And there seems to be a lot of data coming either now and later. Do you have a rough idea of how many experiments that have been conducted for the one-year mission?
Well, I should, because I put together the list of investigations, and as I recall, it was on the order of 17 or so investigations really focused on the one-year mission. That doesn't include the work that was being done independent of the one-year mission, because don't forget Scott and Mikhail are both crew members on the space station with other things to do besides our one-year program. But they really was the focus of the one-year mission, and at least in terms of Scott's work, I recall the number was 17 because that was about twice as many as done routinely on astronauts in terms of medical research that we do on the astronauts. We usually do 7 or 8 or 9 investigations on astronauts on 6-month flights. I thought, being twice as long, we could do twice as much research. I was told that's not really the way it works, but it turned out that we got pretty close to doing that anyway.
Seems like a nice even number to just double it. Now, tell me, have you ever, or have you learned anything about the various countermeasures that have been that you've been trying to work with for the one-year mission?
Well, you make a very good point. The one-year mission is really from the perspective of the Human Research Program, intended to validate and make sure that the countermeasures we've developed up until now continue to be effective for missions longer than the typical 6-month mission. And that's because Mars missions will be on the order of 2 to 3 years. We say 2.5 years, 30 months for a Mars mission, and the work we're doing in the space station is intended to really inform the countermeasures that need to be done on Mars missions, and if possible to develop and validate them so that by the end of the space station era they are validated and available for Mars missions. So we have the countermeasures in work, and you already talked about them: the ARED device, the exercise devices, other kinds of interventions if they're needed, medical interventions, psychological interventions if they're ever needed. So the purpose of the one-year mission is to acquire the data to see whether those countermeasures continue to work effectively on long-duration flights beyond 6 months. And again, that's the data that we're going to be looking at as the mission comes to a close and we get our post-flight data. We really won't be able to tell in some cases how well the countermeasure worked until we get the astronauts back on the ground post-flight and make measurements and see how they compare to 6-month crew members and other crew members in the past.
Now, these countermeasures that you are measuring, do you have a sort of time frame in mind where you would be able to analyze and come up with conclusive results?
Well, the post-flight data collection and post-flight data and sample collection are really front-end loaded, so it's really going to be as quickly as we can get it done immediately after landing. And by quickly, I mean within days to weeks of the landing. So it's not going to be a one-stop, a one-shot kind of thing and then done. But they're going to peter out along about 30 days. But there are some measurements that take place at 30 days and 45 days and 60 days and even up to 9 months after landing for some of the genetic measurements we're making on Scott and on his twin brother Mark. So we're really talking about a lot of data collection very soon after landing, ongoing data collection at a lower level of intensity for several months after that, and then about 6 or 8 months after landing, most of the scientists should have most of the data they're going to get, and they will have already started analyzing the samples and crunching the numbers and coming up with some preliminary conclusions.
And Dr. Charles, last question. Any thoughts about the benefits of doing joint research with the Russians, since the one-year mission did include both Scott Kelly and Mikhail Kornienko?
Well, Gary, that's really the important part of this one-year mission. The one-year mission is not just a one-year mission, but it is a one-year collaborative mission between all the partners on the International Space Station, primarily the U.S. and the Russians, which each contributed a crew member and substantial numbers of investigations. That was my primary purpose in getting involved, was figuring out a good way to do that so we could do that then on subsequent space station missions, that whether they're one-year missions or not. The idea being to increase the efficiency, to make sure that we have efficient use of the resources on board, the crew time, answering questions for all of the partners that need to be answered using astronauts in spaceflight. And that part of it has been remarkably successful, surprisingly successful. I did not expect it to go as well as it has done. Now, that's not to say it was not without a great deal of effort by a lot of people to make sure that that happened. And my hat is off to all the people, U.S., Russian, and others, who made sure that we were successful. But we've had two major flagship investigations. You've talked a little bit about it. One of them, fluid shift study. Fluid shifting involves moving a lot of monitoring equipment from the U.S. segment into the Russian segment and converting the service module essentially into a cardiovascular lab for a couple of days at a time, 3 times in a mission. It took a tremendous amount of coordination between the U.S. and Russian sides, procedures and engineering-wise and safety assurance and things like that. And it worked beautifully all 3 times it was tried. And then post-flight, we have the post-landing measurements in a study that we call field test. Again, a joint U.S.-Russian investigation where measurements are made on the crew members after they land in Kazakhstan, after a 6-month or in this case a 1-year mission, to understand how their human body responds to returning to a planetary surface, in this case Earth, it could be Mars, after a period of time in space equivalent to the transit of astronauts from the Earth to Mars for a Mars mission. That has gone very well in preliminary versions. In the pilot study just last September with Gennady Padalka, we started doing the full-up field test, and this will be the first time we get full-up field test data on 2 people, 1 American, 1 Russian, at the landing site, which will inform us of give us new information essentially on the aspects of human capabilities and performance after a very long space flight upon landing on a planetary surface. All of that is relevant, like the fluid shift study, like the other work we do, preparing astronauts for longer flights beyond Earth orbit, like say to Mars.
Excellent. And we're excited for you as the field tests are coming up in just about a week. So there's a lot of data to study, a lot of more data to come out, and we thank you for taking some time to talk with us today. Dr. John Charles, the Chief Scientist of the Human Research Program here at NASA. Thanks for being with us.
Thank you, Gary. Thanks very much.